All right, looking at class 96, we're going to introduce a new idea of electric potential. So in the do now, number one is all things you know. If you have a ball on a hill, it's going to roll down. That's because it has potential energy at the top, and it gains kinetic energy as it falls. If you want to go the other way, if you wanted to move the ball up the hill, you would have to do work on it. You'd have to apply a force over a distance. Now let's bring this into like the realm of charged particles. So we have a positive charge and a negative charge. The negative charge is stationary. The positive charge is free to move. So if I let go of this little positive charge, where's it going to go? It's going to fall to the negative charge. This is because it has what type of energy? Potential. But not just any potential energy, and I should be a little bit more specific here. I should have written electric potential energy. Now what kind of energy will this be turned into? Kinetic energy, all right, as it falls. So the first one here, by the way, this was gravitational potential energy. This one here is electric potential energy, but kinetic is just kinetic. There's no gravitational kinetic or electric kinetic. Now, if I wanted to pull the positive charge away from the negative charge, I would have to do work on it, apply a force over distance. So as we lift objects up, we increase their gravitational potential energy. We know that. You've known that since an earlier unit. You've probably known it since middle school physical science. We do work on the objects. Doing work changes the energy of the system. You're applying a force over a distance. So if I move a ball away from Earth's surface, I increase gravitational potential energy. Because think about it, it can like fall more, okay, if I move it away. If I take a positive charge and move it away from a negative, same deal. If I'm increasing the electric potential energy, because if you think about it, it can fall more now. Okay, it can do more turning its energy into kinetic energy as it falls. All right, so let's check out how to work on these. So we have to determine if the potential energy is increased or decreased. Here's my rule of thumb for figuring it out. If you have to fight the natural tendency, okay, I know fight is a weird word to use there, the natural tendency of the object, you increase the potential energy. Okay, what do we mean by that? Well, let's look. If you move a positive charge away from a negative charge, what do positives and negatives want to do? They want to come closer together. Well, you are moving them apart. Therefore, you are fighting their natural tendency. You are increasing potential energy. Now let's look at the next one. If you move a positive charge toward a negative charge, again, what do positives and negatives want to do? They want to come closer together. What are you doing? Moving them closer together. Are you fighting their natural tendency? No. So you're decreasing the potential energy. Let's look at C. If you move a positive charge away from a positive charge, what do positives and positives want to do? They want to move away. So by moving them away from each other, are you fighting that natural tendency? No. So you're decreasing the potential energy. And last but not least, D, a positive charge toward a positive charge. What do two positive charges want to do? They want to move away from each other. But you're moving them toward each other. So are you fighting their natural tendency? Yes. Therefore, you are increasing the potential energy. They want to move apart, but you're pushing them, you're squeezing them closer. So they have so much energy in there, they just want to go away from each other. All right? A great review for your quiz would be to play through all of these as if the first charge here that was listed is negative. See how things would change a little bit. But you go through the same process. So here's our equation for electric potential difference. Fancy word for voltage. V equals W over Q. V is voltage. I'm always going to say voltage, but potential difference is a fancier word for it, or electric potential is another word. Think back to the hill example. Okay, this will make more sense a little bit later. W is the energy, or the work done on the object. Okay, energy is the change in energy. Q is the charge. Okay, Q is measured in coulombs. Energy or work is measured in joules. Voltage, potential difference, electric potential, all measured in volts. Sometimes people measure potential difference in joules per coulomb, but we don't really do that. Generally, voltage is what we use. So let's think about our analogy from earlier. Voltage. Voltage is the hill, okay? Voltage is like an electric hill. If you have a bigger, so think of a regular hill that you know. If you have a bigger hill, the ball goes down the hill faster. you have a bigger voltage, the charge moves faster through the voltage. Okay, think about voltage like a battery. Work is the energy needed to carry a ball up a hill, or it's the energy gained by the ball as it falls down the hill. Same thing with charge. The work is the energy gained by the charge when you put it in the voltage, okay, the hill, or the amount of energy required to move it across the other way, voltage. And the charge is like the ball. If you have a heavier ball, it requires more work or energy to move it up the hill, and it has more energy when it's moving, right? 1/2 mv squared. Bigger m is the more energy you have. Charge, same deal. The more charge you have, the more energy the ball has when it moves. Okay, the object has when it moves. All right, so let's look at number 7. Just do some math here. So math is pretty straightforward. How much energy does an electron in a wire acquire from a 1.5 volt battery? That's like a standard battery, like a AA battery is 1.5 volts. So an electron, we know Q for an electron, negative 1.6 times 10 to the negative 19 coulombs. V is 1.5 volts. Plug it into our equation here, cross multiply, and we get that the energy is 2.4 times 10 to the negative 19 coulombs. Negative, but just make it positive for this. Number 8, you're given the charge, you're given the voltage, plug them in, cross multiply, you get 27 joules. For number 9, you're given the voltage, you're given the work or energy, okay, and you need to find the charge. This one's a little trickier because you have to find Q, it's in the denominator. So just cross multiply carefully, multiply both sides by Q, divide both sides by 10, you get 2 times 10 to the negative 3 coulombs. And now we have voltage. V equals W over Q. W is 60 joules, Q is 5 coulombs. Divide, you get 12 joules per coulomb, or 12 volts for the voltage. So it's just important to note that work is required to move an object across a potential difference, but it can also be acquired by a potential difference when it moves through one, right? Depending on which way you go, if you go up the hill or down the hill. So we'll see next chapter that voltage from a battery gives electrons energy to move through a circuit. The more voltage in the battery, the stronger the current.